This is a walkthrough of problem 4 on exam 2 on module 3, which can be found on page 70 in the book Problem Solving Guide for Electromagnetism and Optics. Problem 4 is a proton enters the evacuated space between two plates. Plates are connected to a battery, supplies some potential difference. A proton enters at a speed of 100,000 meters per second at an angle of 30 degrees from the horizontal. Just misses the edge of the bottom plate when it comes in. When it exits, it's traveling horizontally, just missing the edge of the top plate. What's the voltage of the battery? We have a good diagram here. What's going on here? We know the initial speed, we don't know the final speed, we know the angle. I don't know what to do here. Well, let's stall. Let's sketch the path of the proton and see if that gives us any ideas. That's a good idea. There's a nice parabolic path. Hey, this reminds me of a parabola, like you shoot an arrow up at 30 degrees, it reaches the peak. How fast is it going at the peak? We don't know much. We don't know the distance between the plates. We don't know the size of the plates. We don't know the charge on the plates. Can we calculate anything? What about the vertical acceleration of the proton? I don't see how we can get that. Electric field. I don't know. The force on the proton. We can't get that either. We don't have the field. How about the time it takes for the proton to get through the plates? We can't get that. We don't know how long the plates are. Maybe we should raise our hand and say, hey, I think we need the size of the plates and the distance between them to solve this problem. We took a good inventory. We don't know what to do. So this is like you're in the jungle. You're lost. You don't know which way to go. And you evaluated your situation. And you have no idea what to do. And the important thing is to do something. Take your machete and start hacking your way through the jungle. You might realize pretty soon, this is the wrong way. I'm not getting anywhere here. Turn around, go back to the beginning, and start hacking in a different direction. You took a good inventory. You say, okay, now it's time to do something. So let's wait and let's think. Let's think a little bit more. What about the final speed of the proton? Can we get that? I think we can get that. The acceleration in the horizontal direction is 0. So the speed in the x direction, the horizontal direction, doesn't change. We can get the initial speed in the x direction. We just do v initial cosine 30. 86,600 meters per second. And that doesn't change. There's no acceleration in the horizontal direction. So that's the final speed. It's traveling horizontally. When it exits, it's got to be going 86,600 meters per second. Ooh, I think I see it. I think we can get the answer. We have the initial speed, we have the final speed, we have the mass of the proton, we can get the change in kinetic energy. The voltage is the change in kinetic energy per unit charge. We know the charge on the proton. I like it. Kinetic energy initial, 1/2 mv squared. Punching the buttons on the calculator, 8.35 times 10 to the 18th minus 18th joules. The final kinetic energy is 1/2 m times the final speed squared. 6.263 times 10 to the minus 18th joules. The change in kinetic energy is the difference. Subtracting them. Yes, I know it's minus, but we don't care. We just want to know the change in kinetic energy. We know the proton's slowing down. I put the absolute value sign in there. The voltage difference between the plates is the change in kinetic energy per unit charge, and we know the charge, we know the change in kinetic energy. We divide those two, we get 13 joules per coulomb. And a joule per coulomb is a volt. So the proton came in at the bottom of the plate and exited at the top of the plate. The potential difference between these 2 points is 13 volts, which means that's the voltage difference between the plates, which means that's the voltage difference of the battery. So we can calculate the voltage. We still cannot calculate the time. We cannot calculate the electric field. We cannot calculate the charge on the plates, but we know the voltage. That's problem 4 on exam 2 of module 3.